In this video, we'll look at IMAT 2020, question 59. So here we have a concave mirror that's used to produce an image of an object. Here's our mirror here. We've got f as our principal focus and the lowercase f as our focal length along with principal axis. And we're assuming the mirror is parabolic, and we need to work out which of the following statements are correct. So our first statement is that incident rays parallel to the principal axis always pass through f after reflection. So this point here. Is this statement true? So is this true? Well, we can test this out by drawing some example incident rays. So we have one here, it's going parallel to the principal axis. How is this going to be reflected? Well, as it bounces off here, it's going to go in this direction and it will pass through the principal focus. And if we draw another one, we can see that as this hits the mirror, it's also going to be reflected down through our principal focus. And this is true for any ray that's parallel to our principal axis. This is always true. Our second statement is that incident rays passing through our principal focus F travel parallel to the principal axis after reflection. Well, we just proved the inverse, so this one must be true. It's just going in the opposite direction. So if we bring our rays back from our last time, but make them go in the opposite direction, we can see that if it passes through F and hits the mirror, it's going to be reflected on a parallel, and same for our green one here. That is going to be true. So second statement, true. Our third statement is that the image formed is always inverted. So is this true? Let's have a test by putting an object in. So let's say this is our object, and I've put it in front of our principal focus here. So if we draw some rays on, we can see where our image is going to be formed. So if I draw one parallel from the top of the object, it's going to be reflected down here, and if there's one going through the focal point, we can see it's reflected up here. Now our image is going to be formed where our rays merge, but we can see that on this side there is no conversion of rays. However, if we extrapolate our lines out here, there is. So this is going to be where our image forms. And we can see that it is upright. It's not been flipped down. So we have a virtual upright image. So this statement here, that the image formed is always inverted, is incorrect. Then we can also take care of our next statement, that the image formed is always real. Because as we see here, we have a virtual image. It's not real. So these two are incorrect. Our final statement is that the image formed is always larger than the object. So let's test this out. Where are we going to put our object this time? Well, let's put it on this side of the mirror. So here's our object. How are our rays going to be reflected this time? Well, we've got one here, it's going from the top of the object. We go through that focal point, it's going to be reflected this way. And if we have another one going through our point 2 focal lengths away, which is labelled C here, it's going to be reflected like this. And where our lines converge, that's going to be our image. And we can see this time our image is shorter than our object. So this statement is not correct. That means our final answer is answer D.